Alright, so somebody who like kept track of it, yesterday we did, I'm on graph practice 1. Graph practice 1, and yesterday we did 1 from the front. Does anybody remember which one we did from the front? 5. So let's pick a different one. How about 6? So on the front of graph practice 1, I'm doing problem number 6, which is this. While I am sketching my original problem, I need somebody to tell me what that transformation right there does. What?
Oh, notice all the ones below, or all the points below the x-axis line.
Actually, no. That's what number 5 did. See the difference between how number 5 looks and how number 6 looks? Right? So who watched the video?
The whole thing will be inverted.
Izzy? What do we
Whole
do?
thing goes on. Oh, just, okay, so the right side is being like translated to the left
Exactly,
side.
exactly. So, we draw the right side exactly the same as it is. That doesn't change. So nothing's different about the right side of the picture. Then we mirror that onto the left side. So we draw the right side exactly as it is, and then mirror that onto the left. Now, what happened to the trapezoid? It's gone. It's gone. In this transformation, the absolute value of x, we simply draw the right side and then redraw it on the left. That's it. That's how it works. Okay? All right, on the back of that same page, which one did we do on the back yesterday?
It's 8, I think.
8? All right, how about 12? Let's do 12 today. So same picture. What's happening in number 12? What's happening?
Sideways.
We do some flipping. In fact, since there's 2 negatives, that means we're gonna flip everything both ways. So I'm gonna flip sideways first. This negative, remember, is a sideways flip. So I'm gonna go back to the original. And if it was on, this is a sideways flip. So if it was on the left, it's now going to be on the right. Okay, so the trapezoid comes over on the right. The big tall triangle and the downward triangle are now on the left. So look at the original picture. That is this right here. Okay, Kaylee?
What was the bottoms up thing that you're doing today?
That's not what I'm doing here. That was an absolute value transformation.
Right. Why is that one not?
Okay, you need to go back to the front page, and then I'm gonna talk about it, because we already talked about this. 5 and 6 are different. Look at 5 and 6, they are different. So the one we did yesterday, we did that way. This is the way this one is done, because they are different problems, okay? Now, I'm not done with this one though, because why? I haven't done this. What does that negative do? Turns me upside down. So it's gonna take what I just did and totally flip-flop it. So the little triangle's gonna come up. The big triangle's gonna go down. And the trapezoid's gonna come up. Oop, 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 going down. there we go. So that one has been reflected across the x-axis and the y-axis because it had two negatives. Alright? You guys need to keep practicing these things. Alright, put that away. We'll try to practice a couple more tomorrow. Although I think tomorrow we're going to start, the next class, we're going to start our practice tests because we are just not ready for that. That's about how stuff is. All right, so let's go back to our notes, and we are ready for problem E, right? Problem E. So it's another box problem, so let's see who was paying attention yesterday. A square of side x is cut from each corner of a 20 by 24 piece of paper. The sides are folded up to form a box. We need to write an equation for the volume. We need to discuss the domain. And then we need to find the maximum volume. Okay, so it's a three-part problem. Okay, who remembers anything from yesterday?
You have to cut the
Whoa.
X's out.
Megan, what?
I have the equation.
Okay,
So b is equal to 24 minus 2x in parentheses, and 20 minus 2x in parentheses, and then x.
okay, this makes my heart leap for joy, because somebody paid attention to me yesterday when I said okay, we're gonna do a box problem on the test, we're gonna do a box problem on the exam. Every box problem you do, the equation's gonna look just like this. The only thing that will be different is however big this paper is. So she said 24 minus 2x, 20 minus 2x, x. Yes, every time, thank you. All right, who remembers something about the domain? Because it never changes either. Joseph?
0 is less than x is less than
Go ahead.
10.
Yes. Now, I'm gonna write it as an interval. He said it like this. Oops. He said it like this, which means exactly the same thing. Now, always 0. Always. Because you can't cut negative inches out of the paper. So it's gotta be bigger than 0. Why is this 10? Because this number is always what? Half of the lowest one. Half of the smallest dimension. When the smallest dimension is 20, then that number is gonna be a 10.
I have a question. So, on the test, it can say, for like the domain, can you write, the inequality, or can we write
Okay, our focus has been on interval notation, but if you wrote this, I would not mark it wrong. That is the domain. But we're trying to do everything on calculus students, so writing it in notation. But it means exactly the same thing. I'm just gonna be so happy if everybody gets it right on the exam. It would make me so happy. I might skip around the room. All right, now, maximum volume. Maren doesn't think I do it. Maximum, Maren probably doesn't think I can do it. Maximum volume of the box, where does that come from? My calculator, right? I graph it on my calculator. And before I graph it, I'm going to type in y equals. You might have yesterday's equation still in there, so get it out. So we're gonna type in that equation. including the parentheses. And then, anybody remember what else we do before we hit graph?
Then we have to change the
We
window.
go to our window, which is right next to the y equals button. And these two numbers right here that you already wrote down, that's X min and X max. Those are your X's. So this one's going from 0 to 10. And then anybody remember what I said about Y min?
0.
0. Always zeros, the minimum volume. You cannot build a box that holds negative M&Ms. It's 0 or bigger, right? So X or Y min is 0. And then what about Y max? What do we do?
Don't we just like guess it?
We just guess. Now, these numbers are a little bigger than the ones we used yesterday. And didn't we guess like 200 yesterday?
How about 800?
800, all right, let's go with 800. And hit graph. Whoa. Okay, so yeah, so you guess a number, right? And the number is okay as long as what happens?
You can see it go down.
I can see the top of the hill. So, did you see that with 800, did you see the top of the hill? Barely, but we saw it, right? That's all that matters. We gotta see it. So, Dane says he put in, did you say? He put in 2,400. Did you see the top of your hill? Yep. It doesn't matter as long as you see the top of your hill. Alright, so then what do? I got my picture now. So second calc, or second trace, choose maximum and hit enter. Move the cursor till it's on the left side of the peak, on the upward side of the mountain. Press enter. Move the cursor till it's on the downward side of the mountain. Press enter. And then move your cursor to the top of the mountain. Press enter. And down at the bottom, it will give you the coordinates of the maximum. I'm rounding to the 100. 3.62 and 774.16. Is that what you got? If you didn't get that, then you did something wrong because that is the answer. Okay? That's it. Now we need to answer the question, which of those numbers is going to be my maximum volume? So 774.16 cubic inches is my volume. What does the 3.62 stand for? That is the X, the size of the corners. So if you were asked, how big a corner should you cut out? You would say 3.62 inches. Got it? Okay. We have one more kind of problem to look at then, but F is not it. We've already talked about F. How am I going to set up problem F? I'm going to start with my 52.50. And then what's happening to my price? I'm going up to the cash register to pay for this sweater. And there's going to be 2 adjustments made to it. So I'm going to multiply by 2 things. There's no add, no subtract. We're going to multiply by 2 things. First thing I'm multiplying by is a 25% discount. No, you're right. So a 25% discount means I'm going to times by 0.75. I am not interested in what I'm not paying. I'm interested in what I am paying, and that's 75%. But now I've got to pay some tax. So what else am I going to multiply by?
1.07.
1.07. Perfect. Then I'm going to go to my calculator. And it's all multiplied. 52.5 times 0.75 times 1.07. Now, if you write this down like that, I will take points off, because this is a money problem. And a money problem has to be rounded off at the cents, right? So then you gotta decide, is it gonna be 42.13, or is it gonna round up? Money never rounds down. When was the last time you went to the store and they rounded down? Never happens. It either stays the same or it rounds up. So, how do I know if it's 42.13 or 42.14?
If it's the thing after the
The
period.
thing after the,
Second.
my dividing line there,
Yeah.
is that bigger than a half? No. So therefore, the answer to the problem is 42.13. Mrs. Ford will count off if you round wrong. So pay attention, take your time, and round correctly. All right, now I'm going to the restaurant. Food costs $23.12. What's happening? There's a 7% tax, and you leave a 15% tip. Okay, now be careful. Tax is an add-on, right? So is a tip. So we don't have any discounts. Nothing's coming off this price. We're just adding on.
So it's 0.15.
So what do I multiply by? 1.07 and 1.15.
Is it okay if those two are flipped?
Yep, doesn't make any difference. So 23.12 times 1.07 times 1.15. Now I get 28.44916. There's where I'm rounding off. That is a 9, which means this is gonna become 28.45. All right, the last kind of problem that we have to look at is one you've seen before in Algebra 1. It's a mixture problem, okay? In a mixture problem, you have something that you're mixing with something, and you're gonna end up with a new something. So usually it's like liquids, doesn't have to be, but think of it like lemonade. You got some strong lemonade, you got some weak lemonade, you mix them together and you get some medium lemonade, right? That's what a mixture problem is. You can do these in different ways. I am going to show you how I do them. And if you like that, great. If you don't, do it your own way. Just make sure we get the same answer. When I set up an equation, I take whatever the first thing is, the first mixture, I take the amount times the percent of that. And then the second one, I do the same thing, amount times percent. And then I end up with a new amount and a new percent. That's the way I structure my equation. So it's real easy. I have an amount and a percent plus an amount and a percent equal to an amount and a percent. So amount, percent, amount, percent, amount, percent. And every time you do one of these, the percentages are given. So I've got 12%, so there's my percent. I've got 20%. And I'm gonna end up with 18%. So do those make sense to you? Remember, it's amount times percent, amount, percent, amount, percent. Now, there's one more number in the problem, 18 gallons. Where does that 18 go?
In front.
In front here, because isn't the 18 with the 20%? That's important, make sure you put it with the percentage. Now, the question is, how much much? 12%? So what if I called that X? Does that make sense? How much? 12%? Now, I want you to think for a second. Imagine I have a bucket right here, and I have 2 pitchers of lemonade, and I'm pouring in, here's my bucket, I'm pouring in X gallons and 18 gallons. That's what's happening. X of these plus 18 of these. How much is gonna be in the bucket? If I pour in X and 18, what's in the bucket? X plus 18, that's exactly right, 18 plus X, or X plus 18. Aren't we adding these 2 amounts to get this amount? So this is the total over here. So if you add, if I had 6 and 18, that would be 24. So X and 18, got it? Now I have an equation to solve. 0.12X plus 3.6, this is a multiplication, multiplying together, equals, this is a distribute, I'm gonna use my calculator, 18 times 0.18, 3.24 plus 0.18X. Okay, so remember, it's amount times percent, so that's why this is 0.12X. Amount times percent, that's 3.6 on my calculator. Amount times percent. This one is a distribute, so that's how I got this. Alright, now we're gonna solve it.
Yeah, it's X by itself.
Get X by itself, so I think I'll subtract the 0.12 over to here. So now I have 3.6 equal to 3.24 plus, oh my gosh, this is so easy, but it's a bugaboo for people. What is 0.18 minus 0.14?
0.06.
0.06. Now, you are going to have a calculator to help you with all this arithmetic, but that one seems so easy, but a lot of times kids will say 0.6. It's 0.06. All right, now I'll subtract the 3.24. And that's gonna give me 36.36. And then I'll divide 0.36 divided by 0.06. And how many gallons do I need?
0.06 X
Oh,
equals X.
yeah. No, so now I divide by 0.06.
Yeah.
So what's 0.36 divided by 0.06? Use a calculator, don't do it in your head because you're messing up the decimals. 6 gallons. How many gallons of lemonade do I need? I need 6 of them.
Okay, makes sense.
Yep. Everybody okay with that? All right, we got another one, letter I. You can cross off J and K, we're not doing that, you're not gonna be responsible for J and K. So I is our last problem in these notes. This is another mixture, so I'm gonna go ahead and write amount times percent plus amount times percent equals amount times percent. So these are the 2 things that I am mixing together, adding them together, and then this is my result over here, the final mixture. So what are my percentages? Got 22%. Got 74%, and we're gonna end up with 50%. Everybody good with that? Okay. Now, there's one other number in the problem, and that's 100 gallons. Where does the 100 go? Make sure you're pairing it up with the right percentage. It's over here. Now, is the question still how much 22%? So doesn't it still make sense to have that be the X? Okay, now be careful, because these two are going together to make 100. So this is not gonna be 100 plus X.
It's gonna be 100 minus.
100 minus X, very good, Noah, 100 minus X. These two together make 100. So since 100 is the total, to get this amount, I have to subtract X off of it? Does that make sense to you?
Yeah.
You will always have a number, one number somewhere. If the number is here, then this is gonna be 100 minus X. If the number's here, then this is gonna be 100 plus X. Because you're adding those to get this one. Okay? All right, now we start solving. So 0.22X. This is always a distribute. Make sure you're distributing. So what now? Combine like terms. So 0.22 minus 0.74 is going to give me minus 0.52. Did I subtract right? You're gonna have a calculator, so don't worry. Use your calculator. And then what? Subtract the 74. So it's gonna be negative 24. And then divide. And I got 46.15 gallons if I round off to the nearest 100. Did I round off correctly?
Yes.
7.
Did I round off right, guys?
Yeah, you did.
Yeah. Okay. I'm gonna put in my appendix here. So still in here. So Josh is here. Owen, we don't know where he's at. No, Owen's here.
Yeah,
Owen's
Aiden-
there.
Aiden's
Aiden's
there.
absent. All right, everybody good with that? Okay, then what I'm gonna do right now is go ahead and hand out your practice test. And we're gonna start reviewing that.
That's how we got that. Why did you break that? Hello?
Okay. I think I'll wait until we have more people here to hand out the next set of notes. That's what I'm gonna have everybody read on that. All right,
Can I see your
so
paper or
here
was
we
it
go, practice test 1. Now, your test, you know, the math is on it out, is gonna look like this. So there's gonna be a page of graphs for you to do. And then you'll notice that there's a page of word problems for you to do. And then there's a page of other stuff, okay? That's what we got going. So, let's do our page of graphs first. Because that's where it is on this list. All right, so here's our starting shape. This is the shape we're gonna little skinny little triangle down here. And then we have a bigger trapezoid. All right, so I have my original picture drawn. Okay, who can tell me what changes I'm going to make if I have -2 f of
It's
x?
gonna be like double the height, but down, or half the height maybe, or upside down.
Upside down and double the height. So the y's are gonna be doubled and made negative, so they're gonna be flipped over. So these points on the axis aren't gonna change, are they?
No.
Because their height is 0 and it's not gonna change. But this triangle right here, which is down 2,
It's now gonna be up 4.
up 4. Because we are doubling and changing the sign, flipping it. So this trapezoid, where this first point was over 2 and up 3, is now gonna be over 2 but down 6. And over 4 up 3 is over 4 down 6. So there is my picture. Does anybody have a question about that? All right, what's B?
Isn't it, all absolute right?
It's gonna go down 2. Definitely down 2. What does this do to the picture?
All the positive.
Bottoms up. That's bottoms up. We talked about it yesterday. You were supposed to watch the video. This takes only the negative part and flips it. Now, see this negative that was in problem A? That guy flips the whole thing. Everything changes. With bottoms up, only the negative part changes. So the negative, oh, back to the original. The negative part of this is this triangle right here. So that part only is going to get flipped up. Now, what else is happening?
It's gonna go down 2.
Yeah, so I'm gonna go ahead and flip it up. And then the part stays the same. So there's the bottoms up piece of it. Would everybody agree with that?
Yeah.
But now I have to pull everything down 2 blocks. On my grid paper, that's super simple. Everything just comes down 2 blocks. So the pink one is my answer. Anybody have a question about that? Okay. Let's look at C. All right, what's happening in C?
It's going up 1, but isn't it also getting like flipped over, like it just rotates?
Yes, it's getting flipped over. The y-axis is left to right,
Yeah.
flip sideways. So what that means is back to the original. It means The triangle is now going to be over here. Same size, nothing's changed, it's just gonna be over there. And the trapezoid's gonna be over here. So that's my flip. And then, as you said, everything is gonna go up one block. So you're on the graph paper, that makes it so easy. Just everything comes up one block. And the pink is gonna be my answer. You have a test coming up, so you're gonna have to be able to do this, right? Okay. All right, D, what's going on in D? Already talked about it today, who was listening?
The right side is,
This is where I draw the right side, back to the original picture. I draw the right side, which is just my trapezoid. The right side of the picture. And then I draw that very same thing on the other side, right? There it is. Easy peasy if you know the rules. Ooh, last one, a little bit tricky here. I haven't talked much about this. It was in the video also. Izzy, you're my one and only video watcher. Do you remember what happens with this one?
the y gets multiplied, the x
It affects the x, but the x gets divided.
divided by two.
Yep, so x is divided by 2. Or the horizontal is divided by 2. The width is divided by 2. The x's are being divided by 2. So if I look at my original picture, this point right here has what x? This is the point -2, 0. I'm gonna divide that by 2, so that's gonna become the point -1, 0. This divides the width. So the triangle, instead of being 2 wide, he's gonna be 1 wide. So what does that do? It squeezes everything in. All right, what's this point right here in the original?
2.
2,3. But what are we doing? We're dividing x by 2, so it's gonna become 1,3. What's the next point? 1, 2, 3, 4,3. So he's gonna become 2,3. And then this one is 6, 0.
So it's gonna be 3,
It's gonna be 3, 0. So what happened is exactly what I told you would happen. Everything got halved. So the trapezoid used to be 6 across, now it's only 3 across. That's what that number does. All right, next page, here we go, our word problem, good. And we're starting with the box. Does this sound familiar? Write an equation for the volume of the box. What is the domain? Find the maximum volume of the box. Is that exactly what we did the last 2 days?
Yeah.
What's the volume?
13 times 2x plus.
13 minus 2x. And if you start getting confused about that, Joshua, did you just yawn? This is exciting.
Yeah,
13 minus 2x, because didn't we cut those x's off? Minus, we took them off, we didn't tape them on, we cut them off. So 13 minus 2x times 9 minus 2x times, perfect. There's your equation. What's my domain?
0, 4.5.
0, 4.5. Always 0, and where did the 4.5 come from? Half of 9. Why 9? Because 9 is the smallest number, and I do half the smallest number. So now I'm going to go to my calculator, and I'm going to graph this.
Oh boy.
I'm obviously going to have to put in a new equation. It'll be very similar to the one I already have in there, but I have to change it. And I'm gonna change my window
2, 0,
to 0,
4.5 for the
4.5.
then y is gonna be 0.
And I still have 800 in here, but that's probably a little bit big for this one, because these 13 and 9 are smaller numbers.
Call it 250.
250. Graph. Did you see the top of your hill? Owen, you're gonna bring a calculator or you're gonna flunk.
Oh no, mine's dead right
Okay, dead doesn't do us any good, does it? Is that charger right there?
now. Yeah.
Why don't you stick it in the charger, come pick it up Monday morning, unless you think you're gonna need it over the weekend.
No, can I keep it over the weekend?
Keep what?
The
You can keep it in there over the weekend. All right. So you ready? Find it. Second calc. Maximum. Left bound. Enter. Right bound. Enter. Maximum. Enter. Did you get 1.74, comma, 91.44?
Yeah.
So let me answer the question. Find the maximum volume of the box. The maximum volume is 91.44. Put the unit on it. Inches cubed. Cubic inches. Volume. Cubic inches. Easy. Oh my goodness. Okay, number 3. We're going to buy some new uniform pants. Well, what do we know? We know we started with $33.50. 15% discount and 7% tax. 2 multiplications. What am I multiplying by? Megan?
So there's a 15% discount, so you would subtract, 0.15 from 1.
Mhm.
So you should, 85.
0.85, yep, 85%, 0.85.
There's a 7% tax, you add that to 1, so 1.07.
Perfect. Perfect. That's it. One quick type, and you have your answer. 3350 times 0.85 times 1.07. Round it correctly. What's it gonna be?
$30.47.
$30.47, Noah says. Is he right?
Could you make it $30.50 by chance?
No.
Okay, gotcha. I had 17 cents.
Yeah, they don't round everything to the nearest half dollar. We can do cents. Anybody have a question about that? Okay. Next one's gonna be one we just started talking about today. We have an amount times a percent. An amount times a percent equal to an amount times a percent. Does everybody recognize that's what's going on in number 4? We are mixing. So our percentages are 45% and 75% and 58%. Amount times percent, amount times percent, amount times percent. Good? Now what's the other number in the problem?
32.
And the 32 is gonna go with the 75. The question says, how much? Put an X right there, that's what I wanna know. What goes in that last
X
parenthesis?
plus 32.
X plus 32 or 32 plus X, it doesn't matter. Why are we adding them this time? Because these two are getting added. 32 and X are getting added to end up with the total. And here we go, 0.45X plus 32 times 0.75 is 24. How's that equation looked? Okay to you? So now you're gonna move things around, to solve it. So I would probably subtract the 0.45 and subtract the 1856. And I probably should use my calculator because I'm old. And then divide. Round it correctly, this is gonna be, ounces. How many ounces did you come up with?
41.85.
41.85 ounces, that's exactly right. So again, does everybody understand why that's 8.5? Okay, number 5. Last year, the team won 19 games. This year they won 24 games, so they went from 19 to 24. What is the percent of increase? We talked about this yesterday. Percent change. How do we calculate percent change?
The original over, or no, sorry, change over original.
Minus the difference.
It's change or difference over original, right?
Oh,
It's how much they're different divided by the original. So for this one, it's going to be 5 over 19. Okay, so let's make sure we get this in here. 5 divided by 19. This is what the calculator comes up with, okay? It's been long.
5 minutes.
We're gonna write that as a percent, and we're gonna round off to the nearest hundredth. So, as a percent, it's gonna be 26.3157, blah, blah, blah. If, we already agree with that. If I'm going to the nearest hundredth, then I have to stop it right there. So this number right here is the only number it's gonna change, or if it changes at all, it's gonna either stay 1 or it's gonna go to 2. The general rule of thumb is, if it's 5 or more, we go up. So we're gonna say 26.32% increase. So basically, they won 26.32% more games this year than they did last year. Okay, what are the word problems on our test gonna look like? That exact thing. All right, I'm gonna stop there, because there's one more thing I wanna talk to you about, I want you to be thinking about. I don't see you on Monday, do I?
No.
So I'll have to wait until,